Hello everyone, welcome to textmasterstudy.com. Let's solve a problem based on application of first theorem of Castigliano. The question is, the quadrantal ring AB is of radius r. It supports a concentrated load P at the free end A. Find the vertical and horizontal deflection of A. Assume uniform flexural rigidity. This is the quadrantal ring that is given the question. Here the load P is acted at point A. This is the radius of the ring and this is the angle between the radius and the perpendicular distance. Now let's calculate the vertical deflection of A. Here we have to calculate the vertical and the horizontal deflection. So first we need to calculate the vertical deflection of A. That is, let's calculate the moment first. This is the same ring that is given in the question. This load P, this point A, this point B. Now let's calculate the moment for vertical deflection at A. The moment will be here. Let's take a right angle. Here the value is R. So also here the value is R and here the value is also R. But the load will be acted on the effective length and here the value will be R sin theta, which is the effective length, and so also here the value will be R cos theta. So now moment will be load, that is P, into effective length, that is R sin theta. P R sin theta will be the moment for vertical deflection at A. Now let's calculate the strain energy, that is Wi. So the formula of strain energy is m square ds upon 2EI. The limit we will take from 0 to pi by 2. This is the strain energy that is stored in the ring. Let's put the value of m square. In place of ds, we will write r d theta, because let's take a small angle d theta and here the value is r. Here the value will be r d theta and here also the value will be r d theta. So here in place of ds we took r d theta upon 2EI and the limit from 0 to pi by 2. Now let's calculate it. Let's bring this P square r cube upon 2EI value outside the integration. Now we will get for sine we can write 1 minus cos 2 theta upon 2 d theta. 0 to pi by 2 is a limit. Here P square r cube upon 2EI. Now let's calculate it. We will get, let's bring 2 outside. By separating it, we will get this value, and integrating it, we will get d theta is pi by 2, 0 to pi by 2. Here the integration of cos 2 theta is sin 2 theta upon 2. The limit from 0 to pi by 2. Now let's put the limit. After putting the limit, we will get here pi by 2 minus 0, that will be pi by 2. Here, okay, let me write minus 0. Here, let's bring 1 by 2 outside the bracket. Here sin 2, in place of theta we will put pi by 2 minus sin 2. At place theta we will put 0, that value will be sin 0. Here the value we will get, that is pi by 2 minus you can write this outside the bracket. To cancel, we got sin pi minus sin 0, and the value of sin pi is 0, and the value of sin 0 is also 0. So this term will be 0. Here we will get this is the strain energy that we got for the vertical deflection at A. Now let's calculate the vertical deflection, and the formula of vertical deflection is partial derivative of strain energy, that is del Wi upon del P. Now by partial derivating it, we will get this 2 will come outside, that will become 2p r cube pi upon 8ei. By cancelling it with 2, we will get p r cube pi upon 4ei. This is the vertical deflection that we got. If you want to note down, you can note down from here. Now let's calculate the horizontal deflection of A. Before calculating the horizontal deflection, let's introduce a force at horizontal direction, that is Q, whose value is 0. Now let's calculate the moment for horizontal deflection. This is the ring that is given in the question. We introduce the horizontal force Q on the ring whose value is 0. This is R, this is theta. Until here the value is R sin theta. Until here the value is R cos theta. And here this is the effective length on which horizontal force Q will act. The value of this effective length is R minus R cos theta. Now let's calculate the moment for horizontal deflection. The moment will be P into R sin theta. It is in anti-clockwise direction. Now Q into effective length, that is R minus R cos theta. It will be plus because we took minus outside, and the sign of P R sin theta and Q R minus cos theta will be equal because both are in anti-clockwise direction. Here the value will be Q. Let's take the R outside. We will get Q R 1 minus cos theta. This is the value of the moment. Now let's calculate the strain energy stored by the structure. The formula of strain energy is integration of m square ds upon 2ei. the limit will be take from 0 to pi by 2. Let's put the formula of moment. We will get PR sin theta plus QR whole 1 minus cos theta whole square. In place of ds we will write r d theta upon 2pi integration of from 0 to pi by 2. This is the strain energy we got. Now let's calculate the horizontal deflection. So formula of horizontal deflection is partial derivative of strain energy, that is del Wi upon del Q. Here we will not solve this because here we will let the value be like this, because while we partially differentiate it, the calculation will become easier. So by partial derivating the strain energy, we get 2PR sin theta plus QR 1 minus cos theta into partial derivating, the value will be 1R into 1 minus cos theta into R d theta upon 2R. Let me write it properly. Here numerator, denominator 2 will be cancelled, and here by multiplying we will get PR cube sin theta whole into 1 minus cos theta plus QR cube 1 minus cos theta square d theta upon ER value from 0 to pi by 2. Now, as we took the value of Q as 0, let's put the value of Q as 0, so the total term will be 0. So now what we left with is PR cube sin theta 1 minus cos theta d theta upon 2ER into pi by 2. Let's take out PR cube upon EI outside. We will get sin theta 1 minus cos theta d theta now let's integrate it. We will get, let's multiply sin theta into 1, that is sin theta d theta minus sin theta cos theta d theta. Let's separate it. Zero by pi by 2, here 0 by pi by 2. Here the integration of sin theta is minus cos theta. The limit will be 0 to pi by 2. Here in place of sin theta cos theta, we can write sin 2 theta upon 2. Limit from integration, that is 0 to pi by 2 d theta. By putting the value of theta we will get minus cos pi by 2 minus plus cos 0. Here let's take 1 by 2 outside. Now we will get cos minus cos 2 theta upon 2 by integrating sin 2 theta. The limit we will take from 0 to pi by 2. The value of cos pi by 2 is 0 and the value of cos 0 is 1. So we can write 1 minus, let's take the minus outside, plus 1 by 2 and let's take 2 also outside. Now let's put the value of theta, it is 2 pi by 2 minus cos 2 into 0, that will be 0. So let's calculate. Now the value of cos pi is minus 1 and the value of cos 0 is 1. So we will get minus 2. So cancel it with 4, we will get 2. Here PR cube pi upon 1 minus 1 by 2. The value we will get PR cube upon 2 pi. So here we got the horizontal deflection. Thank you.